Hello friends, welcome to Bindu Datwal Chemistry Lessons. Today we'll be doing numericals based on order of reaction. The first numerical:
calculate the order of reaction with respect to the reactant and also the rate constant when concentrations and rates are given.
C1 is 2 into 10 raised to power minus 3 molar and C2 is 1 into 10 raised to power minus 3 molar. Rate 1 is 2.4 into 10 raised to power minus 4 molar second inverse, and rate 2 is 0.6 into 10 raised to power minus 4 molar second inverse. We have to find out the order, so let's write down the rate equation. Rate is equal to K into concentration of A naught raised to power N. For first case, rate 1 and concentration, initial concentration 1. For second case, you can again write down rate 2 is equal to K into A naught 2 raised to power N. Dividing rate 1 by rate 2, we get, K cancels out, we get rate 1 upon rate 2 is equal to, we put the values, 2.4 into 10 raised to power minus 4 upon 0.6 into 10 raised to power minus 4 is equal to 2 into 10 raised to power minus 3 upon 1 into 10 raised to power minus 3 the whole raised to power n. Solving this, we get 4 is equal to 2 raised to power n, or n is equal to 2. So rate law will state that rate is equal to K into initial concentration raised to power 2. To find out the value of K, K will be rate upon A naught raised to power 2 is equal to 2.4 into 10 raised to power minus 4 upon square 2 into 10 raised to power minus 3. 4 into 10 raised to minus 6, this comes out to be 0.6 into 10 raised to power 2 mole inverse liter second inverse.
Determine the order of reaction, rate law, and rate of reaction when concentration of NO2 is 0.50 mole per liter and F2 is 0.60 mole per liter.
So to find out the order of reaction, let us write down the rate law as rate is equal to K into concentration of NO2 raised to power P into concentration of F2 raised to power Q. So for first experiment, we have 6 into rate 1, 6 into 10 raised to power minus 3. Rate 2 is equal to 1.2 into 10 raised to power minus 2 is equal to K into 0.20 raised to power P into 0.05 raised to power Q. And for second it will be 0.40 raised to power P into 0.05 raised to power Q. Dividing equation 2 by equation 1, we get 1.2 into 10 raised to power minus 2 upon 6 into 10 raised to power minus 3 is equal to 0.40 upon 0.20 into 0.05 upon 0.05. This cancels out and answer comes out to be 2 is equal to 2 raised to power P. So P is equal to 1. To find out Q, Again, we use this equation, dividing rate 3 by rate 2, we get 4.8 into 10 raised to power minus 2 upon 1.2 into 10 raised to power minus 2 is equal to k cancels out, and we get 0.40 raised to power p into 0.10 0.05 raised to power q. So on solving, we get this is 4 is equal to, this is 2 raised to power p into, this is 2 raised to power q. But as we know, p is 1, so we get 4 is equal to 2 into 2 raised to power q. Dividing, we get 2 is equal to 2 raised to power q, and we get q is equal to 1. So rate law will be rate is equal to k into NO2 raised to power 1 into F2 raised to power 1. This is solved. Then third is to find out rate. Rate is equal to k into concentration of NO2 0.20 raised to power 1 into concentration of F2 0.05 raised to power 1. So k is equal to this divided by these values. So this comes out to be 0.6 mole inverse liter minute inverse. Now putting the value of k, we can find out the rate. So rate is equal to 0.6 into concentration of NO2 0.50 into concentration of F2 0.60 is equal to 0.18 mole liter inverse minute inverse.
The half-life period for the conversion of ammonium cyanate into urea at 303 Kelvin at initial concentrations of ammonium cyanate of 0.1 mole per liter and 0.2 mole per liter are 1152 and 568 minutes respectively. What is the order of the reaction?
You know that T half is inversely proportional to concentration of the solution raised to power n minus 1. So putting this value and dividing, we get T half 1 upon T half 2 is equal to C2 upon C1 raised to power n minus 1. Putting the values, we get 1152 upon 568 is equal to 0.2 on 0.1 raised to power n minus 1. 2 is equal to 2 raised to power n minus 1. So n minus 1 is equal to 1. So n is equal to 2. So order of reaction is 2.
A first order reaction takes 20 minutes for 25% decomposition. Calculate the time when 75% of the reaction will be completed.
So for the first case, K is equal to 2.303 upon T log of A upon A minus X. So K is equal to 2.303 upon 20 A upon A minus 25% of A. 2.303 upon 20 log of 100 upon 75 or 4 upon 3 or 1.334 9. Log of 1.33 is equal to 0.1249. So on solve the value of k, so t is equal to 2.303 upon k 0.0144 minute inverse, and a upon a minus 75% of a, t is equal to 2.303 upon 0.0144 log of, this is 4, and log 4 is 2.303 into 0.0144 into 0.6021 comes out is equal to 96.3 minutes.
A first order reaction is 15% complete in 20 minutes. How long will it take to complete 60%?
K is equal to 2.303 upon t. T in this case is 20 minutes. Log of a upon a minus x. So 15% complete means k is equal to 2.303 upon 20 log of a upon 0.85 a. 0706. This comes out, k is equal to 8.13 into 10 raised to power minus 3 minute inverse. We write t is equal to 2.303 upon k log of a upon a minus 60% of a. T is equal to 2.303 upon k log of 1 upon 0.4. T is equal to 2.303 upon 8.13 into 10 raised to power minus 3 into 0.3979, and you solve its answer and let me know in the comment section.